All right, we've kind of done some work with conditionals, learning how to do if statements, some of those kind of expressions. We've played a lot with some different number types. We've done a little bit of variable work. We're going to jump right in now and get into loops. So actually, if you have this code here, I'm just going to grab all of it and press delete and get rid of it. We can always add it back if you wanted. You could have done that control /. That would have commented out. I guess I can show that real quick. Control Z, you could have done this, just comment it out. I think we can be okay with losing this. Nothing revolutionary in there. All right, but we want to jump in and we're going to do some loops. Now the major types of loops, there's traditionally a while loop. Actually, I'm going to put this in a comment, otherwise C# will be angry. We have while loops. We have do while loops. We have fors, for each. And those are effectively our looping types now. GitHub Copilot there was trying to provide me some other things, but these are our traditional loop types. The while, do while, and for go all the way back to C. C is a programming language that goes all the way back to the 1970s. If you kind of want to get a little bit of history, we have C, became C++. I don't quite agree with GitHub Copilot there. We actually had, I would say, Java, C#. That's kind of our history of how we get to C#. So if you look at what we're learning here, if you look back at a C program, you'll see things that looks very similar. This notion of having a semicolon at the end of every line goes all the way back to C, or every statement. There's some other languages, like if you look at JavaScript, it has a interesting history, and it actually looks a lot like C# at times. If you use TypeScript, that TS there, it has it looks very similar to C#. I think it has some downsides. It's not as easy to work with as C#, but ironically, TypeScript and C# were created by the same person, or the same mind kind of drove both of them. TypeScript makes JavaScript, in my opinion, a much better language and way more enjoyable to work in. And JavaScript is probably still the number one language out there being used, so it's very relevant. Anyways, that's not where we're going, but I guess my point is, even if you look at TypeScript, you'll have a JavaScript, a while, a do while, a for, and a for each. These concepts go across a lot of languages and are very common. Now, all of them don't handle these exactly the same, particularly around for each. The for each loop isn't in the original C. You have just while, do while, and for. But the for each came around kind of like, I think I know C# had it. I guess I'm assuming Java had it, but I don't know the answer to that right now. Or don't know it, I guess. Look it up, but not really relevant for this. All right, so we're going to do some loops. Now, one of the classic loops we can do is a while true. This is a really probably a bad idea. If we just have a while loop and we do nothing, and I do console.writeLine hello, and I run this, you're just going to see hellos thrown to the console with reckless abandon. And that's not great. It would actually never end. We'd actually have to manually kill the program. Because this while loop is going to keep iterating while true. This condition, whatever's in here, is while this is true, this while loop will continue forever. And if we just say while true, it will never end. So that seems like you could never get out of this. But this comes to another important part of this kind of control flow that people don't think about. There's actually two statements. There's a continue and a break. We're only going to talk about break. If you type break, it will immediately leave the loop, or the most current form of loop that it is in. So if I run this, VM's a little slow this morning. Pops up and just says hello. That's because of this break statement. If I didn't have this, what the heck? We'll live dangerously. We're just getting a ton of hellos. And it will do that forever. But because we have this break here, it exits the current loop. In general, you don't want to do a lot of while trues, but I think they're fairly common when we're building console type applications, just to test some stuff out. All right, let's do something here. We're going to build a program that's going to take in a bunch of numbers, and it's going to take in these numbers, and then we're going to sum the total of them. And we're going to do that in two separate loops. It'll also give us a chance to play with different loop types. We are going to have to jump in to describing some of the different collection types. So this is going to be a little bit of a bigger video, but it's good to know all of this. All right, let's do it. So first we're going to do console right line, enter a number. Now, console.read line, and I'm going to do number string, or actually I'm going to call it input. If, actually let's do that. If they just enter a blank character, we break out of this. I was gonna have them type the word quit, but I think I like where GitHub or the Copilot was kind of leading me anyways. So here we have a very simple program. We're just gonna take in a bunch of numbers. Remember from our previous work, that input isn't a number, it's a string. So we're going to have to convert it to a number. So var number equals convert int. Now that's a little different than what we did last time, right? Previously we did int.parse. And we're going to stick with that for now. Copilot is trying to throw us another way. I do want to point out there's a variety of ways to do things. And often some of them have different advantages and disadvantages. This will be just fine for here. This does have the issue, and we've brought this up previously. If I type in something that's not an integer, we could end up with it blowing up on us, getting an exception, which I'm okay with for this demo app. Now we have a number. Now we need to add it to something. And this is where we need something to add it to, right? You might be thinking of an array, and an array in C# is fairly static. It's not completely static, and I just want to throw that out there. You can change the things in it and get into all sorts of discussions about whether that's good or bad. Not really focused on that now, but ultimately we need some place to put this, and we want to put a lot of these, kind of like a list of them. And there's a bunch of classes we can use to do this, and I'm not even going to begin to hit the majority of these. And for this very first one, we're going to use, well, if we used a list, I just want to point out var, I'm going to call it list equals new int this. And it's going to actually yell at us. No, it wants us to use array.empty instead. Let's not focus here. We are ultimately going to create a new list. And we're going to go int, but we're not going to provide any values in it. We're just going to do this. Surprised? Oh yeah. We have these global using, system collections generic is kind of already brought in. That's kind of Microsoft default. Assumes we're going to want things like this. In the earlier days of C#, we would have had to very explicitly do something like this. Now we don't have to today because of these implicit usings. It's a big win. We don't end up with that as in many files, and we probably want those things in our files to begin with. There's many different types of collections we potentially want. Probably one of the big ones is we want lists, stacks, queues, dictionaries are the biggest ones you'll see in real code. Well, and I'm going to include arrays in this as well. Each of them have their own advantages and disadvantages. I think list is maybe the most common one I'll see used. I guess actually, I'll just keep adding things. Collection. I'm going to put collections. There's also potentially, there is some that really prefer the read-only version of these. Those do have some advantages, so I don't want to not think or factor those in. Those read-only ones do have some advantages, but for right now we're going to focus only on these. Now in each case, we have a class. We have a class list, and when we do new, we create an instance of class list. And if I F12 list here, it takes me to the definition of the class list. Now this is, kind of Microsoft's definition of list. There's a lot of things going on here. Don't expect us to read through this and necessarily pick up all of it. But this is our class list. This is something you may or may not have seen it before. It's referred to as a generic, or it's making because we're using the generic form of list. There is another version of list, and I'm gonna try to find this with system.collections.list. I think, what is it? It's array list. You can use, and nothing will be typed. Everything in this, if we add something to this list, we'll just be adding an object. So every time we put something in this and every time we pull something out of it, we're going to have to cast it. We're going to have to say, well, it's an object. What is it? And cast it to something else. Every time we have to cast something, there's a chance we mess up and we don't actually cast it correctly. I think that's part of the reason not to use this. But to be honest, we probably get that right almost all the time. The big thing is, by not having a generic form of something, well, one, we end up with a lot of extra code, but two, it really kind of just makes working with it kind of a slow pain. It's like that extra code and IntelliSense isn't right. So in general, we would never ever want to use array list. Since they came out with generics, I don't think I've ever intentionally used array list in software. You should always use the generic version. I think the generic version came out with .NET 2, probably around 2005. It was a big win. I was a previous C++ developer from many, many years ago, And I was worried when they were doing generics because C# or C++ has something called templates, which was horrible to work with. C# generics are a breeze to work with, and you should get used to them. Anytime you're doing something with collections, any of these kind of like what I'm calling collection type classes, lists, stack, queues, dictionaries, arrays, and collections, use the generic version. Microsoft kind of already pushes you that way, and just do it. You'll be happier. You'll thank me later. All right, so we have our list here. So we're going to add that number to the list. All right. So what this is going to do, we're going to enter a number 10, 5, and if I just press blank, it exits. All right, so it's going to run through, enter a number. Each time it's going to give us a number. We're going to, if it's blank, we're going to exit the while loop, and if not, we're going to make it into a number and add it to our list. But the only thing we have in here is a while loop so far, which is fine. Originally, this whole thing was on loops. So we're going to immediately jump into the last loop in that list. I'm going to do a for each bar number and list, and we're going to dump all those numbers back out. All right, we are using this for each loop. Anytime we want to iterate over something, this for each loop is a wonderful way to do it. And we're going to do this. Enter a number, 10, 5, blank. Then we exit, and it just dumped 10 and 5 to the console. Pretty easy to deal with. All right. So now let's do var sum equals 0. This is a good point to pause the video and maybe take a couple minutes and update that for loop to do console, or to go through and create that sum. So we're going to add all the numbers in the list. You will notice I already dropped in a message at the bottom. That message at the bottom is just another standard console.writeLine. Copilot had me do it using kind of this parameterized string format. Many languages have some way of doing this. And we put a $sign in front of our string in C#, and then everything within it is normal, but we can then, within these brackets, drop in any of our variables, and it'll just insert into that string for us. We could have written this exact same thing. And this format's, I think, obviously superior to what I'm going to switch to, but we'll go to this. We will do sum. And you're maybe more familiar with that. Either one's technically achieves the same result. I think the first one's more readable. You're often wanting to put things in the middle. You don't need to put them as many of these pluses. You're a little more terse, a little easier to understand. I'd recommend the first format, but we're going to go with this format. So right now, if I ran this sum, because we're setting it to 0, would always be equal to 0. So maybe take a minute to pause, update this for loop to update sum with the addition of all of those numbers. All right, we're back. I'm going to go through and do this work. I'm actually going to get rid of this here. That might be a little number. Sum plus equals number. The plus equals is a common way to kind of add something to itself. This is effectively equivalent of sum equals sum plus the number. So each time through the loop, we're going to add the number to our sum. And what does this do? Again, when we printed it out, it made sense. We went var number in list. It's going to, what does this mean? For each number in the list, it's going to execute the code inside this block one time. And this is a for each. It'll behave much like some of these other looping structures, but with a for each, it's just going to iterate over each item in that collection, or in this case, this list. So let's run this and see what happens. We're going to add some numbers, 10, 5, I'm going to press enter, and the sum of the numbers is 15. All right, we got that in there. All right, now I want you to try two other things. Actually, I'm going to leave this here, but I'm going to comment it out. Oops. That's not what I wanted. I want you to implement this using some of the other looping structures. The other options are for, we're going to do var I. I'm going to turn off. This is. There we go. So, what? Yeah. Heck with that, we'll just leave it on. It's kind of annoying though. All right. I is less than list dot count. Now list also has count as a method or count as a property. Either one will work. It's really common to use the variable I in this situation as kind of that default indexer. Now this is behaving differently in that we are going from I equals 0. 0 is the very first item in our list, while I is less than the maximum item in our list, which in this case would be like previous example 2. We did that example with 15 and 10. And add 1 through each time through this loop, we add 1 to our indexer. And then we can do whatever we want within that code. Here we're doing pretty much the exact same as we are before. Sum equals sum plus. Previously we got to work with just a number. Now we have to do like, well, which item is it in the list? The very first time through it'll be 0. The very second time through it would be 1. And that's where that would give us our value back of 10 or 15. All right, let's run this and see what happens. 10, 5, and it gave us the sum of 15. All right, I also would want you to do a while loop version of this. This gets a little bit trickier because we're wanting to iterate over something. This for loop, the for each is probably the best. The for loop is kind of a natural next version of it. But if we want to do a while, we're going to have to do something like what it's already setting me up to do it. Copilot already knows where I'm going. While I is less than list.count, and that's sum equals sum plus list. All right, let's run this and see what happens. We do 10, 5, blank, we get 15. So in all three cases, we have code doing effectively the same thing. But in all three cases, we're using a different type of loop. We could also use the do while loop. I'll leave that as an exercise if you want to go and do that kind of on your own. This is kind of our light introduction to different looping styles. I think this would be an interesting one. We used a list here. Could you achieve this exact same thing with a stack or a queue? You could, and I think you might want to take the effort to do that. Both in those cases, we have var stack equals new stack int, or var queue equals new queue. Both could result in some different code here. So go through and let's modify this. Let's make all 3 loop types run each time. Sum equals 0. And we have to null sum out each time. Right? It's angry. I'm kind of getting set up so we can run all 3 sets of code at once. It's angry about this. And it's because we have, we're reusing this indexer I. In general, we don't want to reuse things. Reusing things in the programming world is often going to get us into trouble. So we want to avoid it if we can. It's kind of lame. I'm going to call it I2. Really creative here. I'm going to label this one while in the text here. Label this for, and we'll label this for each. So we kind of see the number for each one. All right. Let's run this. Enter number 10, 5, our standard, and all 3 of them produced the same sum. That's cool. You're doing pretty basic math. Hopefully it worked. But now let's go through and let's use a stack and a queue to do the same thing. Now, if you haven't been through the different data types, I think could be a little confusing. A list is pretty much what it sounds, just a line of numbers or a line of whatever it is. A stack is a tiny bit different. With a stack, you're always putting something on top. You can almost think of it as a stack of papers. You're always putting another piece of paper on top. So the next time you want to access something from a stack, you're taking something from the top. So it's kind of like that pile of papers on your desk. You're putting things on there and you're pulling the top one off. A queue is just a line at Disneyland. First person line is going to be the first person to ride, and the last person line is going to be the last person to ride. And each has their own different types of behaviors. We're going to go ahead and modify this program. If you want to pause this video and try to do it yourself, that might be good. But if not, we're going to work through this right now. Okay, we're going to go through and we're going to do stack.push. All right, we stack.push and queue, we're going to enqueue it. This one is going to put another item to our list. This one's going to push it to the top of the stack, and this one's going to add it to our queue or our line. Now to sum them, we're going to have 3 sums now. We're going to do sum list var sum stack and sum q. All right. Now this one we're going to have to change to sum list. Right? Now this is a little interesting with the for each loop and a stack. We really, actually we are not going to do this using each type of loop. Actually, I'm going to put this back to sum. We're backtracking a little bit here. Put these back. We will at the end here, I thought it'd be good to kind of show them all in parallel, but it's not always the easiest. So we're going to do this. All right, so we're going to do sum. We're going to use a stack here. And the reason I'm doing it this way is probably a while loop or a do while is going to be our easiest to get things out of a stack. We could do it the other way, but I think it will be a little confusing with the for loop. I think it actually might be kind of a little bit tricky. And then I'm going to do this using a while stack. And so we kind of have a while loop and a stack, and then numbers, this sum. If we're going to do the queue, queue is going to actually behave a lot like a stack in that we're putting things into it and pulling things off. If we think of it, a stack is first in, first out. Oops. And a queue is last, or no, a queue is first in, first out. Sorry, this is a queue. And a stack is last in, first out. All right, I messed up we'll put some comments here. I guess we've been doing the stack first, so we're going to put this right here. Now a queue, we're going to do effectively similar. Oh, I need to put my variables in the right order. And I need to drop this line in here. And queue. Number 10 and 5. All of them have the same answer, so that's good. A variety of ways to achieve the same result. We have quite a few things going on here, but let's take a look. We're going to do something. We've been kind of building this application. We're going to set a breakpoint, and I want us to run this application. These breakpoints are a critical way for us to interact with our software. Debugging is the bigger topic. We have to be good at this if we want to write software. If you can't debug your software, it's going to be a pretty difficult process to work on it. We got to be able to do that. Here we have a list, a stack, and a queue. So if we use F10, that's the key to kind of go through the next line of code. It's pretty common. You'll actually see that in a variety of editors and environments. Press F10, go over the next one. Next F10, we went over all of them. F10 is going to be one line at a time. We can do things to jump into individual items. We can actually, while debugging, if I hover over a list, it will eventually show that list. Took longer than I was expecting. Hover over the stack, it shows that stack. We can actually pin these, so it just kind of always lives here and kind of is always there. I almost never ever use that pinning, but I just want you to be aware that it can be useful. We'll actually maybe use it today, even though I traditionally never use it. So we're going to step through this while true. We're going to do this enter number. We're going to ask to enter to read line. So it actually pumps the console back up for us, because otherwise, what would we know to do here? I'm entering my standard answer 10. This is not null or white space, right? So we're going to go to this line. Parse this. We get a number, 10, and we're going to add it to our stack and our queue. Now if we look at our list, it has one item. Our queue or stack has one item. Our queue, one item. Go back through again. Enter our number. We're going to read 5. Again, this is not null or empty. We're going to parse it. We get it as a number, which should be the number 5. And we're going to add it to our list and queue. Now, if we look at list, it has 2 items. Stack, 2 items. Queue, 2 items. Stack, the very 0 item is 5. That's curious. Look at list, the 0 item is 10. If we look at queue, the 0 item is 10. It gives us a little bit of a clue into what's different about these. Turn a number, we're going to read a line here. I'm just going to press enter so it skips it. Oh no. I'll put a breakpoint here just so I don't miss it. There we go. I thought I'd maybe missed my line and we had jumped out. But hit that break because it is null or empty and went to here. Went to the sum right now is 0. We're going to step through it. We've seen this kind of code function many times for each item in the list. It's the very first time. Number is a 10. Come back through. Next time, number is a 5. And when we add, our sum is now a 10. When we add sum, which is 10, plus 5, we're going to get 15. And it's going to exit our for loop because it's the last item. And then we're going to drop to the console for each is 15. Boom. Now we're going to reset sum. Then we're going to do the exact same thing using a for loop. We're going to jump through. Our I is going to initially be 0. And we're going to do sum equals 0. The list equals has 2 items. The 0 entry is 10. So we're going to get 10. No, where am I? Here we go. Jump through again. Now it's 15 because that was 10 plus 5. So again, pretty basic here. Set sum to 0 again. We're going to do the while loop. Oh yeah, we started getting, we got that little error there. That's why I use I2. This is going to behave a lot like this for loop. I2 is 0, so this very first time. Sum is 10. You'll notice here, because the for loop has this nice ability to I++ each time, in the while loop, we kind of have to do that manually at the bottom. I didn't call that out earlier, but it's something just to be aware of. Again, the better loop for the job will be a little more concise for that. Now it's 15, so we did 10 plus 5, 15. We increment I again. I is now 2. 2 is not less than 2. 2 equals 2. So this is false. We jump down to here and we dump this. Now we're going to do our sum for our stack. Now here, because the stack has effectively a number of items that we need to process, we're going to start with stack and just how many items. If there are items in it, we need to keep looping. And stack pop. Which item is it going to pop off? The 5 or the 0? Well, after we hit this line, we'll know for sure the 5. Everything else we've done, we got the 10 first. But remember, stack's a little different. You're putting things in, and last in is going to be the first out. Last in, first out. So we're going to step over this again. We get a 15. Now we're going to go through a queue. Queue also has just a number of items. We're just going to go through it. To add things to our queue up above, we did in queue. To remove things from our queue, we are going to do a dequeue. It's kind of just to remove things. Now here, we do this. Do we get the 5 or the 10? We get the 10. And if you look at our queue, it only has one item left in it, and it's the 5. This is a first in, first out, a line at Disneyland. Go through it a second time. So queue is now 15. And we now have, oh, very, very interesting. We have a bug. Look at that. The sum is not sum queue. All right, we're going to pause here. We're not going to pause. We're going to go ahead and let it run, but we didn't. This code is not right. We have to do Control C. This should be this. And sum stack should be right here. Look at that. A little issue. All right. If we ran it again, we'd get the same numbers. If we change something, we should probably run it. I'm going to skip these. I can just do continue. 10, 5, blank. Gets us down to here. And I'm just going to continue to the bottom. And where the heck is my control flow? Oh, must need an enter there or something. But anyways, all of them still produce the same result. Not super advanced code. This is kind of a good warm-up or kind of an introduction to some of these looping structures. You're probably looking at this going, what are all the different ways this can behave? What I recommend you do is just do what I did here, step through and walk through it with the debugger and play with different options. Try to do things to break it. And ultimately, if you do break it, that's fine. That's what we want to do. We want to, it's really nice about code is just text in a document. It's pretty easy to change. All right, go ahead and continue to play with that. I think next we're going to get into some methods, classes, and some of those things. Start trying to really build out our programs.